Okay. Okay, guys, welcome and good morning.
Morning.
Good morning. And before I start, any questions? Good, good. Okay. So yesterday we started talking about pulse. We saw as was okay, yes, a number of cycles grouped together. Yep. Okay. Now, in context to the pulse, we said we talked about what we call pulse duration, which was the time from beginning of pulse to end of pulse. Clear? Okay. And mathematically, it's okay. It was going to be equal to number of cycles in the pulse times period. Okay, sorry. Now, today's topic is going to be what we will call spatial pulse length. Yeah, okay. Now we all know it's okay what a pulse was. That was okay as that. I guess it's okay. A group of cycles. So if we take a pulse, like this one here. Yeah, okay. Now the word here is going to be length. Length, which means to me it's okay. The word for distance. Yeah, okay. Now this second term here, which is spatial. Now L is, that's going to be, it's okay, our very favorite. Pertaining to. Okay, where this is going to be space. Okay, which you can make as okay, yes, okay. This space here could as okay be in terms of mainly as okay distance, length, area. Is that clear? So mainly as okay, just pertaining to. space or area or distance or length. That will be, yes, okay, what we mean by spatial. Okay. Did that make sense?
Yes.
Good. So what is going to be your spatial pulse length? Okay, now this is because of the name, and I'm not going to be writing it every time. We're just going to just, okay, abbreviate it as S, P, L. Yeah, okay, which means, okay, will stand for spatial pulse length. Okay. You may at some time also see that they only write the word pulse length. Okay, which is the same as your spatial pulse length. Okay. So what is it that the spatial pulse length is going to be? We can say as, okay, is going to be the distance. Let's say as, okay, length of a pulse. And we can say as, okay, from the beginning of it, of the pulse, yes, to the end of the pulse. So if we said that this here is, okay, was the pulse, your spatial pulse length is going to be the distance or the length of the pulse, which starts from the beginning of the pulse to the end of the pulse. We can mean it as, okay, this thing here, that will be the spatial pulse length of the pulse. Clear? Okay, we mean as, okay, measure from the beginning of the pulse to the end of the pulse in terms of distance or length. Whereas what we said yesterday, that, okay, yes, if we measure from the beginning of the pulse to the end of the pulse in terms of time, that was what we call the pulse duration. Did you guys get that?
Yep.
Good. Any questions?
Not yet.
Good. Now, next thing will be as, okay, what is going to be our unit for this thing here? Now, it should be as, okay, very easy to guess that, because, okay, it is a length from starting to beginning. Yeah, okay, which is going to be as, okay, any unit of distance, but we can mean it as, okay, things such as millimeters. Okay, you can go centimeters, you can even, yes, okay, go micrometers if you want to. But any unit of distance or length can be used to specify the value of your spatial pulse length. Did you guys get that?
Yes.
Okay. So are you guys seeing some similarities here? Right, okay. While in chapter 3 was a period, now here's okay in terms of a pulse became a spatial, or became a pulse duration, right? While in your previous chapter was wavelength, is in this for a single cycle, is in this case, okay, for a pulse is going to be referred to as a spatial pulse length. Did that make sense? So it's me going to be as okay, you can say copy and paste. What can be copied and pasted? What can be copied and pasted? The units, right? Clear, okay. Period and pulse duration, time. So the unit will be as okay, any unit of time. Wavelength and spatial pulse length. Both would be as okay measured in terms of distance. So yes, okay, the unit will be the same. Right? Good. Now, guys, the typical value. Clear? Okay, and the typical value of a pulse length is 0.1 millimeter to 1 millimeter. Right? Where this 0.1 millimeter here is the same as 1/10 of a millimeter. Is that clear? So that connection is okay, be the same as 100 micrometers. But that's going to be as okay, you can say it's okay, the smallest length of a pulse, not of a cycle, but of a pulse. Okay, which had more than 2 cycles. And then you can also talk about, okay, what was the wavelength of those cycles. But this typical value here, remember. Okay, so the typical value of your spatial pulse length, remember that one. Now, guys, what I said yesterday was, okay, as better imaging, higher frequency, and things like that. It's primarily as okay, not really directly as okay for the period, but more as okay in terms of the spatial pulse length that it is important to as okay have a high frequency, which means as okay will give us a low spatial pulse length. Now, before going into yes, okay, how it's okay, what determines the spatial pulse length, let's just talk about a bit about yes, okay, the formula, but it's going to be easy, yes, okay, to understand. always okay, there will be always okay, what determines the spatial pulse length. So mathematically, guys, your spatial pulse length is going to just okay be, and we can say, okay, mathematically, so we'll need two factors to determine the spatial pulse length. First, it's going to be the number of cycles. And just to be more specific, what I mean by the number of cycles is going to be, it's okay, number of cycles in the pulse. Yeah, okay. And what that will be is that's going to be multiplied by the wavelength. Okay, now when I say wavelength, what does that mean? That's going to be as okay the length of a single wave. What does it's okay specify as okay of a cycle? So these two factors here, yes, okay, are going to, when it's okay, they are multiplied together, give you, yes, okay, the distance from the beginning of the pulse to the end of the pulse, which will be the spatial pulse length. Did you guys get that?
Yep.
Good. Okay. Now, guys, I briefly, yes, okay, mentioned that yesterday. The number of cycles that we had in a pulse. The number of cycles that occurs we had in a pulse. Okay, that was mainly wholly and solely as okay going to be determined by the transducer. Okay, whether the pulse that we had, for instance, okay, had 2 cycles, whether that pulse had 3 cycles, whether it has 4 cycles, 5 cycles, 6 cycles, 7 cycles. Okay, but that number of cycles that okay is going to just okay be making up a pulse that is wholly and solely determined by the transducer. As a matter of fact, yes, okay, this number here is fixed as per transducer. Did you guys get that?
Yeah.
Good. So we can say here, it's okay, what's going to is okay end up determining is okay your spatial pulse length is transducer. But then we also see that, okay, as your spatial pulse length is determined by something else, which is the wavelength of each cycle, right?
Yep.
Okay, where we, for instance, okay, had a small wave, whether we have a wave with a bigger wavelength, or we can say, okay, whether we have a wave with a even bigger wavelength. Okay, now this wavelength here is okay, guys. What determines your wavelength?
Source and medium.
Both source and medium. Clear? Okay, but it's going to be these waves, or you can say, okay, the wavelength of these waves here, which is going to make up the wavelength. Clear? Okay. So the sound wave is okay produced by the transducer. Okay, that's okay. That's going to be as okay the transducer here as well. by gain, yes, okay, also is going to be determined by the medium. So that's why we can say as okay, your spatial pulse length, mainly because it is primarily as okay, one of the factors that play a role in what the length of the pulse is going to be the wavelength, which is determined by both your transducer and your medium, which we in this case is okay, we'll call the tissue. So that's why it's okay, your spatial pulse then is going to it's okay be determined by both of these. Did you guys get that?
Yes.
Good. Any questions, guys? Okay. So mainly because we can put it this way and say it's okay, mainly because okay, wavelength is one of the factors used to yes, okay, determine what the spatial pulse length is going to be. Okay. That's why it's okay. And since wavelength is okay was determined by both the source and the medium, that's why it's okay. Your spatial pulse length is going to be determined by both source and medium. Now the last thing is okay, is this dude here? Is she or he adjustable? And the answer for that is no. Clear? Okay. Why? First of all, it's okay for two reasons. We can say it's okay. The number of cycles of a transducer, yes, okay, that was fixed as per the transducer. Clear? Okay. Likewise, yes, okay, we could not adjust the period. Okay, which would have had an effect on the wavelength. Yeah, okay. So likewise, okay, we cannot adjust the wavelength, which okay plays a vital role in because it's okay determining how short or long our pulse is going to be. Okay, at least okay as far as okay the transducer is concerned. Not to talk about okay, we have no influence upon is okay what the wavelength is going to be is okay once it travels through the medium. That's going to be pretty much okay the speed of that medium that will determine that. So here, yes, okay, again, just like wavelength was not adjustable, so is the spatial pulse length not going to be adjustable because the number of cycles was fixed, and but okay, yes, the wavelength of the transducer was pretty much okay as fixed as well. Yeah, okay, so if things are fixed, yes, okay, that will mainly mean that we are not able to adjust them. Yeah, okay. You want to just okay have a trans or you want just okay scan with a lower wavelength or spatial pulse length. Well, okay, there's two ways of doing it. Either it's okay choosing a transducer which has less number of cycles per pulse. Did that make sense? Or choose a transducer which has or which produces cycles with a shorter wavelength. Did that make sense? Clear? Okay. So, guys, Now we talk about the relationships. Now we say, yes, okay, spatial pulse length. Now it's okay, we just first of all, it's okay, look at, okay, what is it that we had in the formula? We had number of cycles in the pulse. Yeah, okay. And yes, okay, that was going to be, yes, okay. We can say it's okay, multiplied by the wavelength. Now, my guys, your spatial pulse length may be longer, or you may, as okay, have a pulse with a great spatial pulse length. If you either had a pulse with great number of cycles, and or if those cycles had a great wavelength. Did you guys get that? Or on the other hand, we can say, yes, okay, the other way around, you may have a spatial, or you may have a pulse with a short spatial pulse length or a short length, either because that pulse had less number of cycles, and or if those cycles had a short wavelength. So what did that establish? It may, as okay, just establish the fact that your spatial pulse length is directly proportional to, yes, okay, the number of cycles in the pulse. And or likewise is also going to be, yes, okay, directly proportional to the wavelength. Did you guys get that?
Yes.
Yep. If not, let's just do it this way and say it's okay, we have a pulse. We have a pulse here, it's okay, with a low number of cycles. Okay. And we can say it's okay, in this case, it's okay, we keep, it's okay, the wavelength constant. So we can just have, it's okay, two examples with two different number of cycles. Now the lower number we can say is okay, we just had two cycles. For the great number of cycles, we can say it's okay, we have four cycles. But just to keep is okay, to establish the relationship, we can say it's okay, we have the wavelength of okay, yes. That says okay, 0.3 millimeters. So in both instances, it's okay, yes, our spatial pulse length in this case here will be 2 multiplied by 0.3, which becomes 0.6 millimeters. Whereas, okay, in our other case here, is okay, where we have a greater wavelength, the spatial pulse length will become 4 multiplied by 0.3, which becomes 1.2 millimeters. And you can say mainly it's okay. See, just because of yes, okay, increasing the number of cycles in the pulse, the V is okay, the spatial pulse length increased. Hence prove that okay, as the spatial pulse length is directly proportional to the number of cycles. Now again, yes, okay, we can also establish that relationship for our wavelength and say yes, okay. The number of cycles here in both cases will be yes, okay. Let's just say 4. Where we yes, okay, will actually have yes, okay, 2 wavelengths. We may have okay as a greater wavelength. We can say yes, okay. 1 millimeter. And or we may have a shorter wavelength. Let's say it's okay. 0.5 millimeter. Well, in this instance, okay, what's going to be as okay, our spatial pulse length with the greater wavelength is going to be as okay. 4 multiplied by 1. 4 cycles, 1 millimeter per 1 millimeter wavelength of each. So in this case, it's okay, the spatial pulse length is going to be 4 millimeters. Clear, okay. Whereas in the other case, it's okay where we have a shorter wavelength, the same number of cycles is going to be 4 multiplied by 0.5, which is half. Where we actually is okay, in this case, we just have a spatial pulse length of just 2 millimeters. Yeah, okay, so hence prove yes, okay, when we reduce the wavelength, we will have a shorter spatial pulse length. Whereas, okay, as if we increase the wavelength, or we have okay a greater wavelength, we will have a greater spatial pulse length. Did you guys get that? Good.
Yes.
Okay. Any doubts? No doubts? Good. Now, guys, what do we know? That our let's put it this way. Do you guys know of some old relationships that we can put in here? Let's just do it this way. Now we set the spatial pulse length. Yes, okay, it was equal to the number of cycles of pulse, okay. Oh, I'll say it's okay per pulse. Yeah, okay, and that was multiplied by the wavelength. Right, okay. We just established that, okay, yes. Both of these fellows here, okay, were directly proportional to the spatial pulse length. Now, guys, the first thing that we may as okay say can be as okay established here, or we already know is that, or because it's okay, we also know the wavelength is also going to be as okay directly proportional to a fellow that we call period, right? Right?
Yep. Right.
Good. So just look at it in this way, guys. Because if it says, okay, number of cycles per pulse, multiplied by period, what did we call that?
Pulse duration.
Very good, dear. Pulse duration. Okay. Okay. Now we can take a pulse. We can take any pulse and say, it's okay, what do we have in either pulse? Where we calculate the wavelength or spatial pulse length, or whether we calculate the pulse duration. We can say it's okay that we have a pulse. Let's say it's okay, 1 cycle, 2 cycle, 3 cycles. Okay, so this pulse here has a total of 3 cycles. Did you guys get that?
Yes.
Good. Now, what's the next thing that we could say that, okay, yes, if we, for instance, okay, measure the distance of each cycle from the beginning of the cycle to the end of the cycle, that was what we call the wavelength. Yeah, okay. Whereas if we, for instance, okay, measure the time that it took one cycle from the beginning of a cycle to the end of the cycle, and measure that in time, that would be the period. Okay. Where we already have established that, okay, as wavelength and period are directly proportional. But for this pulse here, it's okay, we can say it's okay, where did we measure the number of, or where did we measure the spatial pulse length of this cycle here, or this pulse here, right? Okay. It was going to be in both cases, okay, going to be determined by the, by the number of cycles. Shit. Yeah, okay. Now we can just assume that, okay, in this case, yes, okay, the number of cycles is okay. Was true, but 3, sorry. Okay. Then we can just say, okay, it has a wavelength of, let's say, okay, 0.1 millimeter. Yeah, okay. Likewise, for the period or spatial pulse duration, sorry, we can say, okay, we had 3 cycles. Okay. But in this case, as okay, we may just say that, okay, the period, for instance, is going to be as okay. That just says, okay, 0.2 microseconds. Yeah, okay. So what's going to be as okay, or spatial pulse length? In this instance, it's going to be as okay, 0.3 millimeters. What's going to be as okay, or pulse duration? That's going to be as okay 0.6 microseconds. Did you guys get that?
Yeah.
Good. Let's just do a little thing here. And says, okay, we still have, okay, yes, a pulse with, let's say, okay, just 3 cycles. But let's just say that, okay, in this instance here now, the period, or sorry, let's say, okay, the wavelength of each cycle is, let's say, okay, is 1 millimeter. So what is going to be, okay, our new spatial pulse length? Is going to be 3 multiplied by, okay, 1 millimeter. Right, okay, which will become 3 millimeter. Right? Did that make sense?
Yeah.
Yes.
So what we did was, okay, now we increased the wavelength. But what do we know that's going to happen is, okay, when we increase the wavelength? Well, so is the period going to increase as well? Because, okay, they were directly proportional. So in this case, here we can say, okay, the period might have even increased to, is okay, let's say, 0.2 seconds. That's metaphorically, that's okay, to 2, that's okay. 0.2 microseconds to 2 microseconds. Now we still have, yes, okay, 3 cycles, right? Okay. Okay. But the period of each of those cycles now was now 2 microseconds. So our pulse duration in this case is, okay, gets to a total of 6 microseconds. Okay. Which mainly just means that, okay, yes, since it's okay, when wavelength increases, the spatial pulse length increase will also, is okay, mean that, okay, the period will also increase. We will cause the pulse duration to increase. So hence, due to that, we can say it's okay that your pulse duration is directly proportional to the spatial pulse length. Or if you don't want to go into all that, you can mean it's okay, just say it's okay, whatever pulse we had, the number of cycles, okay, the number of cycles that we had in a pulse, whether that was for pulse duration or spatial pulse length, okay, that number of pulses, also not number of pulses, sorry, number of cycles. Okay, this is a common factor in both, right? Right? When we calculate the spatial pulse time, that's okay. What do we use? Or what was the that we needed? We need to know, that's okay, the number of cycles, right? So that's okay, we may calculate, that's okay, our pulse duration. What do we need to know? Your number of cycles in the pulse, right? Okay, so whether you calculate pulse rate, or it's okay, pulse length or pulse duration, the number of cycles in a pulse, that's going to be as okay a common factor between these two, right?
Right.
Good. Okay. Now what do we have as okay in pulse duration? Is okay. Now that's going to is okay be multiplied by period, right? Whereas okay, as for your spatial pulse, that's okay. That number of pulses was going to is okay be multiplied by wavelength. And what we know was that, okay, now these two dudes here, they were directly proportional to one another. Okay, that you mainly says, okay, now, whatever number of pulses that we had in a pulse, okay, or whatever number of cycles we had in a pulse, the period of each cycle is going to be as okay direction to, it's going to be directly proportional to the wavelength of each cycle in that pulse. Okay. Where those number of cycles in the pulse multiplied by the period will give you your pulse duration. Where, okay, yes, the number of cycles in a pulse multiplied by the wavelength of each cycle in that pulse will give you as okay your spatial pulse length. Where the wavelength is directly proportional to the period. Okay. So yes, okay, longer period, longer pulse duration, which will give you as okay, and that longer period will cause a greater wavelength, which will give you as okay greater spatial pulse length. So your spatial pulse length is directly proportional to the pulse duration. Did you guys get that?
Yeah.
Is there anybody who is LOST? Right, okay. Let's say it's okay, two of you is okay, strike a deal with one another. Or one of you will be as okay, the spatial pulse length, one of you will be as okay, oops, the pulse duration. What are your plans for the quiz? What plans do you have for the quiz? Nothing?
Study for it.
Okay.
Pass it.
Okay.
Show up.
Okay. If you don't, then I can't help you with that. But let's just say it's okay. Let's make it a little bit festive. Yeah, okay. So I said, well, okay, two persons, that's okay. One will be the pulse duration, one will be the spatial pulse length. Okay, you can say it's okay, show up, show up. That's it. Okay. But one will say is okay, the more apples you bring, I will bring an equal, or I guess okay, or a proportional number of oranges. Okay, so one of the people say, well, like I will only bring in, it's okay, 5 apples. So for 5 apples, that's going to, for each apple, that's going to be 2 oranges. That person will have to bring in 10 oranges. Yeah. Okay. So what we end up having is okay, 5 apples and 10 oranges. But that person who is okay are going to bring in the apples say, well, I'm going to bring in 10 apples. Now for each apple that's going to have to be brought in 2 oranges. So the person who brings in oranges will now have to bring in 20 oranges, right? Yeah, okay. So that's your relationship between spatial pulse length and pulse duration. That the more okay apples are being brought in, the more oranges will be brought in. You can okay, count of apples is and oranges is as okay. The spatial pulse is going to be the period and what the hell do you call that, wavelength. And we already know that they are directly proportional, right? Not reciprocal, not just okay reciprocal, just directly proportional. Greater wavelength in space, it would take a longer time for that cycle to complete. Whereas, okay, we had a shorter wavelength in space, lesser time. Did that make sense? So your pulse duration becomes directly proportional to the spatial pulse length. Yeah, okay. The easier way of thinking is that, okay, as the uncommon factor in the two equations was wavelength and period, where these two dudes here as okay were directly proportional. Where okay, the number of cycles and the number of cycles, that's okay, that was the common factor. And okay, yes, of course, if we talk about a specific pulse with a specific number of cycles, well, okay, that's going to be it. Okay, we say it's okay, a pulse with a short wavelength may mainly as okay mean that this is going to as okay be a wave with a with a short period as well. Clear? Okay. Whereas okay, as if we had a similar pulse, okay, with the same number of cycles, but where we say it's okay that this was going to be as okay a cycle with a with a great wavelength, then that will also as okay have a equally greater period. Which is just okay multiplied then by the number of cycles in that pulse. Did you guys get that? So what we now can say is that your spatial period or spatial pulse length, sorry, is okay, yes. Directly proportional is okay to the number of cycles. Oh my God. Let me just number of cycles. It is also directly proportional to the wavelength. So was just okay, our pulse duration was directly proportional to the number of cycles. It was also directly proportional to the period. Now we can also say that, okay, yes, that this wavelength here was directly proportional to period. We then just established the fact that spatial pulse length will become directly proportional to pulse duration. Did you guys get that?
Yes.
Good. Now, guys, what else have we established? Yesterday, and in chapter 3 as well. Isn't it known that period is inversely proportional to frequency? Yes, guys.
Yes.
Good. So what would think, or it's okay, it's not really a new relationship. It's mainly it's okay, just the old relationship that we copy and paste, because we also know that okay, as wavelength as well is going to be inversely proportional to frequency, right?
Right.
Good. The EUAS okay established this far yesterday and said shit, sorry. Okay. That okay, as the pulse duration is okay was inversely proportional to frequency. Clear? Because it was directly proportional to period. So what make you think otherwise? But yes, okay, establish this fact as well that okay, your spatial pulse length is, of course, going to be inversely proportional to frequency. Did you guys get that?
Yes.
Yep.
Okay. As we said yesterday, my friend's enemy is also my enemy. Did that make sense?
Yes.
This group's friend is this group, and we have a common enemy. So guys, just so we have it on black and white. Spatial pulse length was directly proportional to the number of cycles in pulse. Was directly proportional to the wavelength. It's also going to be as okay directly proportional to the pulse duration. and it's going to be inversely proportional to the frequency of the waves. Whereas, okay, on the other hand, we say that pulse duration was also directly proportional to the number of cycles per pulse. Was going to be as okay directly proportional to period. Was going to be directly proportional to as okay the spatial pulse length, then also as okay inversely proportional to frequency. Yeah, okay. And we can okay just say it's okay why this, because this is equal directly proportional to this. Because in the other sense is okay why this, because this is directly proportional to this. Which mainly is okay, then also is okay establish. Yes. And as I said yesterday, guys, please do not confuse the number of pulses or number of cycles in a pulse with the frequency. Okay, okay. Clear? Okay, you can't say, okay, this pulse here only got 3 cycles. Okay. It's the period of each of those cycles that's going to just, okay, determine reciprocally as, okay, what the frequency would be of that sound wave. Yeah, okay. There's still going to be as, okay, and what is it that the frequency will account for is that if those cycles continued for 1 second, the number of cycles that you have had in 1 second will be the frequency of that sound wave. Did that make sense? So it was going to be the number of cycles in a second that would account for the frequency of that sound wave. Okay, but just because it's okay, a pulse only got, let's say it's okay 3 pulses, and another pulse got, let's say it's okay 6 pulses. That doesn't make the sound wave with 6 pulses having a higher frequency versus that with just 3 pulses, or 3 cycles, sorry. Did that make sense? Okay, well, we'll determine which of these two, yes, okay, pulses had a high or low frequency was going to be the period of each cycle. Did that make sense? Clear? Okay, because you can have, yes, okay, a pulse with a great number of cycles, but of a low frequency. Clear? Why? Because the period of each of those cycles is great, and vice versa. Okay, so 3 and 6 cycles per pulse does not determine the frequency of that pulse. That's going to be the period of each cycle. And of course, it's going to be inversely related and reciprocal. Yeah, okay. So you may be given questions where they say, okay, 2 pulses are produced by, okay, a 2 system, yes, okay, produces such and such pulse. Okay, with 2 cycles and 4 cycles, 3 cycles and 6 cycles, 4 cycles and 8 cycles in a pulse. Which of these have the highest frequency? You won't be able to tell, because you need to know what the period of each of those cycles is to determine whether they have a high frequency or a low frequency. Did that make sense? Yeah, okay. Now, likewise, that's okay. Let me just ask you guys, are you guys in for reading crappy handwriting? Let's do this. If not, I can always read it out. So here's a question. You can say it's okay, 2 scanners or systems are producing sound pulses. Get one has 6 cycles in a pulse. The other has 4 cycles in a pulse. Yeah. They have the same frequency of 2 megahertz. Which has the greatest spatial pulse length? I'll be back in a second. Yes, guys. Lost? Two scanners are producing sound pulses. One has 6 cycles in a pulse. The other has 4 cycles in a pulse. They have the same frequency of 2 megahertz, which has the greatest spatial pulse length.
One with 6 cycles.
The one with 6 cycles. Okay. Okay. Christian, do you want to tell us how you got that?
If they have the same frequency, that would mean they have the same period, so it's just got 2 more cycles in its pulse. Should make it longer.
Okay, exactly. Okay. But, well, okay, yes, your logic is okay. But it's okay, it's spatial pulse length, so you guys say more like a wavelength. But that's okay. Yeah. Did that make sense? So you can mean it's okay to say it's okay, since this is the same, then okay, yes, for both of them, it's okay. They will have okay, yes, the same wavelength, whichever. Yeah, okay. Did you guys get that?
Yeah.
Good. So let's say it's okay that was okay, yes. One of our questions. Part 2 of this question can be so which has the greatest wavelength, right? Or spatial pulse length, sorry. Our next part could be what's the spatial pulse length of the pulse?
I think I got it.
Hmm.
So like what's the spatial pulse length of each one?
No, not of each one. Of the pulse, because we said, okay, which pulse has the greatest pulse length, right?
Yeah,
Okay.
oh, so the one of the greatest, it would be 3, right?
Yeah. Well, let me just be gentle with you guys here.
What does that say?
Estimated.
Okay.
Is it not 3?
How do you find it without knowing the wavelength?
Huh?
How do you find it without knowing the wavelength?
Because you have the frequency, so it's just inverse of that, right?
Okay, but how?
Oh, geez.
So what did that become? This is your wavelength. That's estimated. So you're allowed to round it up.
You add the two together, right?
Why we add them?
Because you have two separate scale. Like you're, yeah, they're gonna have two answers, right?
Yeah, but we already got the answer one. The one at 6 cycles had the greatest spatial pulse length.
So you're asking what is the spatial pulse length of the one with the greatest cycle?
Yes,
5.
5. Okay, yeah. You can say 4.6. But you can ground that up to become, that's why I say, okay, 5. 5 what?
Millimeters.
Millimeters, okay. Right? Okay. 5, yes, okay, guys. It's mostly, yes, okay. You're probably not going to see a question like this. At least not the second part. The first part, yes. Okay. The first part, yes. You will see. But that's okay. That's made. That's okay. Just having if you have a good understanding of the concept or relationships, you should be good.
I have a question.
Yes.
So would you just assume that it's going through soft tissue and to use the
Yeah.
1.54?
Yeah. Okay. If yes, okay, is anything else but soft tissue, the question will answer it or state it. And even if it is soft tissue, yes, okay, it will most likely, yes, okay, tell you.
Okay, thank you.
Okay, guys. So if I were in your shoes, I would ask for a break, sit down, and read the relationships, or a cup of coffee. Don't go in front of the fireplace yet. Read those off. But, and I will see you guys back at no later than 10:40. Should we make, okay. So read on your spatial pulse now, read on your pulse duration. Okay. And the relationships. And guys, before returning back, make sure that you have an understanding on the relationship of period and frequency and what they are measured.
When we come back, can we do like another example? Or like something like what we just did, just to like, I don't know, make sure we got it.
Okay. Let me see what crazy ideas I can pop up with. Okay. Okay, then I see you guys at 10:45. Now, before I bombard you guys with the cues, any cues? Nope. No questions? Okay, then I got a couple of questions for you guys. So here's your question. Now a system produces a pulsed wave with a pulse duration of 3 milliseconds. Is that clear?
Yes.
Now the pulse has 6 cycles. What is the period of each cycle in the pulse? So a system produces a pulse wave with a pulse duration of 6 or 3 milliseconds. The pulse has 6 cycles. What is the period of each cycle?
I think I have it.
You think you have it? Okay. Did anybody get the answer? Okay, Kathleen, what do you think the answer is?
Half a millisecond.
Half a millisecond. How
Or
did you get that?
microsecond. Microsecond.
Oh, your
No.
pulse duration was milliseconds,
Okay, so it's
not the
millisecond.
microseconds. It is half a millisecond. Puzzled? Nice. I hope I don't have to teach this. We said pulse duration was, well, okay, yes. Number of cycles multiplied by period. Clear? Okay. Now what we want to is okay, divide, okay, find out here is period. So the question is, okay, yes, because all a matter of, okay, is just have period at one end of the equal to sign, and on the other side is going to be, or okay, as well was pulse duration. So what do we do with this number of cycles? We mainly says, okay, we're going to divide both sides with number of cycles. So here's, okay, this will cover all this, and that means it tells us that the pulse duration divided by the number of cycles is going to be equal to period. And then you just put the numbers in. So your pulse duration was 3, the number of cycles was 6. Off. And then just a unit, milliseconds. Is that clear? Was that how you got it?
Yep.
Good. Is there anybody who didn't know how to, yes, okay, flip around with an equation like this? Just look at the word equation. What does it mean? That one is what is going to be on one side of the is to equal sign has to be equal to, yes, okay, what's on the other side? So one side is, okay, you multiply two factors to get a parameter, if you want to put it that way. You may divide that parameter with one other factor to get the other factor. Did that make sense? Okay. Now let's just assume. Let's just assume, and let me see if it did make sense. Let's just say that, okay, it's not that your pulse duration had been, yes, okay, made up of, okay, as number of cycles plus period. If that was the case, what would you have done then to find the period?
Subtract number of cycles.
Which, excellent. So you subtract the number of cycles on both sides. So this will cut out this, and okay, then there's a number of cycles subtracted from period. Okay, good. Good. So, hey, you know math, you just don't have confidence. Good. But this was just part one of this question here. Clear? Okay. So what did we get? Or period to be? Sorry. So okay. Half a millisecond, right? Right?
Yep.
Good. Now part 2 is the cycles in the pulse. So what is going to be the frequency of the cycles in the pulse? So what is the frequency of the cycles in the pulse?
I don't know. Is it 0.3?
So you said 0.3. What? 0.3 what?
Um, Microseconds?
Okay.
I got 2 hertz.
Me too.
Me too.
To what?
Hertz per second.
No, my dear, there's nothing known as hertz per second. It's either 2 hertz or 2
Okay, 2 hertz.
cycles per second. Okay, 2 hertz. Okay.
Yeah, I'm
Yeah, 2
wrong.
kilohertz.
Okay, somebody has 1,000 times. Okay. Yes. Okay, guys. Now, first of all, what is the unit of frequency?
Hertz.
Hertz, kilohertz, megahertz, gigahertz, so on so on. Yeah, okay. So it can't be seconds, milliseconds, or so on so on. Is that clear? Right? Now, what did we mean by a frequency? How did we define frequency of sound wave? Does anybody want to tell me how frequency is defined?
Cycles per time, second.
Cycles per unit of time, where here it says, okay, the unit of time is going to be seconds, right? Okay. Clear? Okay. Now, guys, now what did we need to get there? Yes, okay, we needed to know, yes, okay, what the period was. And it is going to be, yes, okay, we're reciprocal to 0.5. which would be 2. The number as reciprocal to 0.5 is 2. And milli was 1/1000. So the remaining meter here we go with a kilo. And okay, per second here is millisecond, is not serious, okay. Hertz. Is that clear?
Yep.
Good, yeah. So, and that's what I said. The frequency is going to be determined, is going to be accounting for the number of cycles that have been completed in a second. Whether that pulse was of a millisecond, microsecond, 2 milliseconds, 2 microseconds, 3 milliseconds, 3 microseconds, whatsoever. Clear? Okay, but frequency is going to be as okay, what would be the number of cycles completed in a second? All this, okay, your pulses are going to be as okay, fractions and fractions of seconds. Not to talk about it's okay, the period is going to be as okay, even a fraction of a fraction of a fraction of a fraction of a second. Okay. Okay, that was just one question. Are you guys ready for the other one?
Yep.
Okay, now you can all thank Caitlin for this. Okay, guys, here we go again. So our question is, if two pulses have the same pulse duration. Clear? But different number of cycles. Which pulse? Oh, let's say it's okay. Let me word it this way. Which of the two pulses has the greatest spatial pulse length? Now we have two pulses with the same pulse duration, but each pulse has different number of cycles. Now, which of these two pulses here will have the greatest pulse, spatial pulse length?
Can I guess?
Yes, Jenny, what do you say, my dear?
Is it okay to guess, or
Yeah, you can. Once you got the answer, go ahead.
it's the one with less cycles? No? Because if you have less cycles, wouldn't they be longer? If it's the same pulse duration. No.
I was gonna
I know.
say,
Okay, let me read the question again. Now, two pulses have the same pulse duration, but different numbers of cycles. Which of the two pulses will have the greatest spatial pulse length?
wouldn't they be the same?
Yeah, I was gonna say they'd be the same too.
Okay, so you say they will be the same.
Yeah,
Okay, girls, why do you say that?
because the duration of both of the pulses is the same. So the length of it is the same. Doesn't matter the different number of cycles that you have in there, though.
Exactly. That was the that was the crazy thing. Clear? Okay. So I'm gonna say it's okay. Lower frequency, higher frequency, this, that. Well, okay, the answer is within the question itself. That when you have the same pulse duration of two pulses, they're going to have the same spatial pulse length. So neither of them has a greater or longer pulse length because they have the same pulse duration, right? Did that make sense? Did you get that, Jenny?
Yeah, I think the word
Okay,
problem just
so
threw
it's
me.
yeah. Sometime, yes, okay. You may just be bombarded with okay, yes, crazy info. But this was just part one. Are you guys in for part two? Good. So what we have established, okay, yes, neither of them have, yes, okay, a greater pulse length. Clear? Now comes the next question of part two. Which of the two pulses will have the greatest period?
The one with the lower number of cycles.
Exactly. Good. Now, honestly say, did you guys get the same answer? Or were you somewhere else? Okay, guys. But one thing is, okay, you may find my questions a little bit more weird than the questions written by the author. So tomorrow, if I write a book of ultrasonic physics, don't buy it. Now, okay, guys. Now, before I go on to next topic, let me see. It's okay. Next pair of topics. A couple. Is there anybody who has any doubts about period and frequency? No. How they are related?
Reciprocal.
Reciprocal. Clear? Okay. What is the unit for period? What's going to be the unit for period? Huh?
Time,
Time, exactly.
seconds, yeah.
Seconds, milliseconds, microseconds, hours, days, centuries, millenniums, whatever. Clear? Okay. What's going to be the unit of frequency? Either the number of times that event, which frequency is okay, we are talking about, occurs in a unit of time. Clear? Okay. In the previous chapter, we said, okay, yes, that event that we talked about was a cycle. Clear? Okay. And we says, okay, the number of cycles that we had in a second, that was going to be the frequency of that sound wave. Did you guys get that? Clear? Okay. And when we said sound or period was not only inversely proportional to the frequency, but also reciprocal. Now, dear guys, that's okay. When we talked about period and frequency, and we established that relationship, I think I told you that, okay, please make sure that you are on top of this relationship here, because it's going to be repeated again and again and again and again. So that first again is now, or what we will talk about now. But this whole chapter here was not about cycles or waves, but rather about group of cycles, a group of waves that we call a pulse. Right? Did you guys get that?
Yeah.
Good. So the first thing that we will talk about is going to be, yes, okay, the pulse. Repetition. Period. So what would that be? Now this pulse repetition period, guys, okay, is what you may see me do over and over and over again, mainly as, okay, just abbreviated as P R P. Yeah, okay, guys. So this is going to be as, okay, our, we can say as, okay, more or less official abbreviation of what we as, okay, call a pulse repetition period. let's just talk about, okay, what do we mean by pulse repetition period? Now, guys, let's say that, okay, here we have a pulse. Which was following is, okay, another pulse. Is that clear? So we can say, okay, we have two pulses. We say, okay, we have pulse A, and we can say, okay, pulse B. Now the word repetition here is mainly as, okay, about as, okay, we can say, okay, repeated. And when we say period, we mean is, okay, going to say, okay, that's going to say, okay, we measure in terms of time, because period was mainly as, okay, something that we measured in time. Okay, but the thing that we're going to measure in time is not going to be as, okay, the period of each cycle. That will not, but mainly as, okay, what is going to be the period between the, at which a pulse is being repeated. So pretty much, guys, this here, when it's, okay, measured in time, is going to be as, okay, the time at which, or it's, okay, between is, okay, one pulse and another pulse. Or as you may see, it's, okay, it is going to be as, okay, the time from the beginning of one pulse to the beginning of the next pulse. Is that clear?
Yeah.
Okay, so if you measure it's, okay, the time from here to here, or if you say it's, okay, this was the first pulse, followed by this pulse here, then it's, okay, this time span here is going to be as, okay, when we measure it and say, okay, as, and as, okay, in terms of time, will be as, okay, your pulse repetition period, because that's going to be the time between, as, okay, one pulse being followed by another pulse, or when the pulse will repeat itself. Yeah, okay. So what we mainly see here is that, okay, as this pulse repetition period here, pretty much, okay, yes, is going to be as, okay, the okay, let's see. Yes, okay, the pulse repetition period is going to be made up of two things. One, what we as, okay, in the beginning of the chapter called on time, which we also as, okay, refer to as, okay, as the talking time, of which we also as, okay, if you look here, it's going to be as, okay, your pulse duration, right? Did that make sense?
Yes.
Okay. And what did we call this time? Yeah, there was no cycle produced by the transducer.
That's the off time.
That was the off time. Very good right there. Or what we also had was, okay, we just called it listening time as well. So mathematically, it's okay, your on time and off time. Or we also just call the listening time. The sum of those two is going to be equal to, yes, what we call the pulse repetition period. Because let us put it this way. The transducer produces a pulse. Run. Then it's silent. Run. Then it's silent. Run. Then it's silent. Clear? Okay. So what will be the pulse repetition time? It will be as the time from the beginning of run to run. Okay. Whereas in that period, yes, what do we have? The production of the pulse and the off time. Clear? Okay, which was made as just that time span between, you can say, the end of one pulse to the beginning of the next pulse. But then you have another pulse followed by its own silence, off time. Did you guys get that? Okay, so here's roughly speaking, is what is going to be is your pulse repetition period is going to be as the time from beginning of one pulse to beginning of another pulse. Did you guys get that? Any questions? Yeah, okay. So the reason that we call it a period because we're going to measure that span of whatever in terms of time. Yeah, okay. So it explains as what's going to be the unit of your pulse repetition period. It's going to be as measure unit using a unit of time. Millisecond, microsecond, seconds, whatever. As long as it's a unit of time, you can say, well, yes, this is the period between one pulse and another pulse. Did that make sense? Any questions? Yep. Good. Now the typical value for this one here is Hakuna Matata. Clear? Okay. Hakuna Matata. Don't worry about it. Okay. Just make sure that you know that yes, it's going to be expressed in a unit of time. Millisecond, microseconds, whatsoever. Is that clear? Okay.
Yep.
Good. And just a matter of common sense that yes, your pulse repetition period. Your pulse repetition period is always going to be greater than the pulse duration. Why?
Because pulse duration is just the on time.
Mhm.
And pulse repetition is on time and off time.
So you can say, it's you add some more time on to on time, which takes up the pulse repetition period, right? Okay. So on time is only going to be or the pulse duration or talking time is only going to be a small fraction of your entire pulse repetition period. Did you get that? Any questions? Okay. Now I was gentle with just your typical value and say, okay, oh, don't worry about it. Clear? Okay. And the reason for that is, the math that we're going to come up with now. So the mess. And now this thing here is going to look more and more and more like ultrasound. Do you guys mind if I go to another chapter on a page?
Go for it.
So pulse repetition period. Now here, guys, is determined by. And that's going to be your source. Did that make sense? Now, for two reasons. You can say it's okay because it's partly dependent upon your pulse duration. But then yes, your off time. Now just keep in mind here, guys, your pulse duration is going to be fixed for a transducer, no matter whether you, for instance, increase the pulse repetition period or whether you decrease the pulse repetition, that's probably the wrong color. Decrease the pulse repetition period between pulse and pulse. So your pulse duration is for this transducer here is fixed. As we said when we talked about pulse duration. Because what was the pulse duration was determined by? Well, the number of cycles that you were having a pulse, which is fixed as per the transducer's makeup. And likewise, what is going to be the period of each cycle within that pulse was wholly and solely as determined by the transducer and not adjustable. Is that clear? But
Yep.
if you go, just a second. Oh, sorry. Yes. See, you were there.
I was just saying, yeah.
Okay, good. Okay. Now, ladies, and the gentlemen as well, of course. If you go and say it's okay, and if you look at yes, was your PRP adjustable? And the question for that is yes. The question for that is yes. Now, you say, well, okay, as the pulse duration is fixed, so that may mean that, okay, the pulse duration here that is not the adjustable part. So yes, okay, the pulse duration is fixed, which means okay, it is not adjustable. How is it that we still be able to, yes, okay, either increase the positive P or positive repetition period or decrease the positive repetition period? That is pretty much okay, going to be as okay by either increasing or decreasing your off time. That's going to be how, yes, okay, you actually, yes, okay, will increase the pulse repetition period or decrease the pulse repetition period. Although the pulse duration is still going to be as okay fixed. That won't change. Clear? So how is it that, okay, yes, that the pulse repetition period is okay? Still we, yes, okay, will be, yes, okay, determined by the source. Because now here is okay by the source. We will actually, is okay, mean the ultrasound system. Now, before I get into that, if you paid a little bit attention on day one, no, not the beginning day of chapter 4. What did I say? We had continuous waves, right? You guys remember that? Blah 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 blah, no stop. But then we also had pulsed wave. And what did I say? That interval between each pulse or the off time was going to be utilized.
Is that the reflection off the tissues?
Coming up.
Is that the reflection of the sound waves off the tissues?
Okay, but how would that be possible? You are on the right note, Christian, but how? Okay, guys, look here. Pulse produced, travels, come back.
Is it the depth?
Listen to what I say. Don't jump ahead. Pulse produced, travel, come back. Travel, come back. So that off time between one pulse and the other pulse. Why did we have that? Mainly so that that pulse could travel to a certain distance and return back. So when that pulse returns back, that's when, okay, just okay, the next pulse will be traveling out and then come back. Clear? Okay. So the system or the machine would not know automatically or by itself how far or it's okay, close to, it's okay, send that pulse that it produced. That's going to be your brain that will set that. And how do you do that? Because, okay, there's going to be a knob on your keyboard. And guys, if you look at the keyboard, like I say, of your ultrasound, that's okay, you have the regular keyboard with, okay, as your letters, numbers, and alphabets here. Clear, okay. The other day we said that's okay, usually that's okay, up here in the left corner, we had, okay, that's what we call power. And most systems, guys, at this point here, so okay, we'll have a knob, and that knob is going to be called depth. It's going to be labeled with depth. Did that make sense? Now, just like any knob, yes, okay, when you turn it clockwise, that will increase the depth. Where, okay, yes, if you turn it counterclockwise, it will decrease the depth. Did you guys get that?
Yeah.
Good. So the off time here, guys, mainly as okay was just going to as okay give the pulse here enough time. So you can see it's okay to go and come back before as okay the next pulse will be produced. Okay, which will have its own off time. We are going to do it's okay be enough for that pulse to go and come back. Go where or so and so. That's all something that you set on your system. Clear? Okay, so we can actually okay adjust, or we can adjust the depth, and by do so, that's how it's okay we determine our pulse repetition period. Okay, by the source, which means it's okay is going to it's okay here be your ultrasound system. So what can we say now? Do you guys mind if I go to another slide?
No.
Good. So what can we have now? Yes, okay. We can have a pulse. We can say, okay, we can have a pulse. And we can say, okay, we can have a pulse. These were the pulses that we had. And okay, yes, in between each of these pulses here, yes, okay, was our, we can say, okay, off time, right? Okay. Did that make sense? Okay. But this whole thing here, from here to here, or from here to here, or we can say, okay, from here to here. That will be our pulse repetition period. Okay, but we mainly can say it's okay that our on time, as we call it, or talking time, or as okay, pulse duration, they were fixed. So practically, it's okay, they should have been the same, but okay. Clear? Okay. Where okay, the only thing that was okay as adjustable was off time. And what that off time actually is okay causes is that okay, yes, we may have okay as a greater or shorter pulse repetition period. Now let's just do it this way and say it's okay. Let's just say that okay, in this instance, okay, we have a great pulse repetition period, mainly because okay, we ended up having okay as a great off time or listening time. Yeah, okay. Where okay, yes. What would it be like as okay if we had a shorter pulse repetition period? Yes, okay, short pulse repetition period. That we can see is okay. It's just like this one, okay? And we can go on and on. Right. Yeah, okay, yes. You can say, okay, that there was the same transducer that we used. But that's why it's okay, we still have okay as the same pulse duration, which was okay as fixed. But it's okay, what you may see here is okay that we have is okay, we have our off time, which is lower. And due to yes, okay, that lower off time is okay, where is it we also end up having comparing to up here is okay, we will have a lower pulse repetition period. Did you guys get that? But how did we get this greater pulse repetition period or lower pulse repetition period? Mainly as okay, because what we did here was our image was going to be of a greater depth. We can say it's okay, 5-10 centimeters. Whereas in this case, it's okay, the depth of our image would have been of a lesser depth. Let's say it's okay, 5 centimeters. Yeah, okay. How did we go from, let's say it's okay, from this depth here, A, to B? That we actually says, okay, that we decrease the depth. That was that depth knob that mainly as okay, just were turned counterwise or anti-clockwise. It mainly as a cause that we went from sorry, so a greater depth. OMG. It's okay. We went from a greater depth. Oh my God. Sorry. From a greater depth to a lower depth. Whereas, okay, if we turn it anti-clock, if we turn it clockwise, okay, what that would do is that we actually okay went from a lesser depth to a greater depth. Clear? Okay. Mainly it's okay by just increasing the off time. And mainly it's okay giving That's okay. In this case, that's okay. The pulse at greater time to travel to the depth of 10 centimeters and come back. Okay. Whereas, okay, as if you turn it the other way around, well, okay, it's going to be a shorter distance that the pulse will have to travel. So that's okay. It will take it a shorter time to go and come back. Okay. So the system, guys, is actually going to, okay, or actually it's programmed. Let us put it this way. The system is actually programmed to determine the pulse repetition period based on medias, okay, or just assuming that the sound is going to be traveling at a fixed speed in the tissues. And what would that speed be? It uses the speed of soft tissue. Did that make sense? But it will say as, okay, since I'm set to run a greater distance to go and come back, I will need a greater time. Clear? Okay, whereas, okay, if the distance is shorter, then of course that's okay. If you run at the same speed, it's okay. It will take you less time to go and come back, right? Now, do you guys remember somehow associate geography of it, okay, what we have in the surrounding of the school? No?
Buildings?
Okay, of course, that's okay. We are not located in a field of nowhere, right?
By the water.
Okay, guys. Okay, listen. Right next to the school, what do we have? There's a gas station, right? Okay, you're going from the school towards 95. Okay, let me throw it that way. Not to Dutchess way, you have to spend your whole break, it's okay, to make a sandwich and fries made. Right, okay. Okay, good. So right next to the station, or right next to the school is a gas station. Okay, you cross the street, what do you have on the other side? Across the other, there's a Dunkin' Donut. Okay, you go further down, it's okay, then maybe it's okay, another gas station. Now, guys, this is how we'll be doing it. Let's put it this way and say, it's okay, each of you will be a pulse. Each of you guys will be a pulse. Clear? Okay. Now, if somebody say, well, okay, I want you, it's okay, go and fetch something to eat and drink. Well, I say, well, okay, listen, dear, you can only go to the gas station and come back. Okay? Because it's when you go and come back, yes, okay, when you come back, I will be able to send out the next person to fetch his or her lunch or whatever. And he or she is also only going to allow to go to the gas station and come back. Okay. Now, what about that? Okay. There was a shorter distance between, you can say, okay, the school or the classroom and the gas station. So you will take, okay, lesser time to go and come back, each of you, right? Okay, so what I mean, the time period between is okay, a student going and a student going and a student going, which is going to be, as okay, says, okay, the student leaving the classroom repetition period, okay, will be shorter compared to, yes, okay, if I said, well, okay, listen, guys, okay, you guys are now allowed to go to the Dunkin' Donut and come back. Now, since that is a greater distance, what would that do? That will cause that you take greater time to go and come back. That greater time will be a greater pulse repetition period. Or if I'm so nice, I say, okay, yes, you can go to, yes, okay, the gas station down by the highway and come back. Of course, that's okay. Now, since this is a greater distance, that will take you greater time to go and come back. Did that make sense? So what do we call this greater time here to go and come back? Pulse repetition period. Because when you come back, that okay, the next person can be sent out. Did that make sense? So what is it that we are doing by increasing the depth of the image? Well, okay, two things. Well, okay, you may say, well, okay, I don't just want to, yes, okay, visualize a structure that is a depth of 5 centimeters. We need to visualize something which is at a greater distance or a greater depth. Okay, or deeper down. Did that make sense? So what you actually will do is, yes, okay, you will increase the depth of your image from 5 to 10 centimeters in this case here, right? Okay. Clear? Did that make sense? Now what's going to be, yes, okay, what we can say is, okay, the adverse effect of that is that it will take a pulse a greater time to go and come back, which mainly means that, okay, yes, the time between, yes, okay, a pulse can be repeated will increase. Did you guys get that? So with greater depth, if the pulse repetition increases, and with lesser depth, the pulse repetition period decreases. What is going to be the relationship between your pulse repetition period and the depth, or let's say, okay, depth of image?
Directly?
Directly related. Hallelujah. Where we made is, okay, just can make it colorful here and say, well, okay, with a greater depth. Shit. I never said that word. You will have a greater pulse repetition period. What's this? Or it's okay with a shallower depth of image, which is this. You will have, okay, as a lower pulse repetition period. Did you guys get that?
Yes.
Good. Now, just two small things, and okay, yes, then you guys can go on your break. And you have an image here. Let's say it's okay, we were at a depth of 5 centimeters. Yeah, okay. So what you will see, now some systems just okay, may it's okay, do it like this. Some system, yes, okay, may do it like this. It doesn't really matter. But you may see as okay, small, usually that's okay, just dots. Or as okay, may just be as okay, lines like this. Okay, along the image. Okay. And what you guys would need to know is that, okay, yes, the distance between, let's say it's okay, this dot and this dot here, or let's say it's okay, this marker here and this marker here, is going to be equal to 1 centimeter. Okay, so usually it's okay when we have okay as an image depth of 5 centimeters, you can say it's okay. This is going to be as okay 1 centimeter deep. This will be 2. This will be 3. This will be 4. And okay, of course, that's okay. This line here will be 5 centimeters. So you can mainly say, okay, if you see a structure, let's say here, you will know that okay, this structure is okay, it's at a depth of 2 centimeters. You may see something as okay, let's say it's okay, right to this one here. That's going to be at a depth of 3 centimeters. And whatever you see in between here, let's say, it's going to be as okay between 2 and 3 centimeters depth. Yeah, okay, but what you will see as okay, as you, for instance, okay, increase the depth of your image. Now the size of the image itself is going to be as okay fixed. But it's okay, we went from let's say 5 centimeters to let's say it's okay 7 centimeters. Now what are you going to see is okay, you'll see a dot for 7 centimeters. Okay, it's 6, 5, 4, 3, 2. So it's okay, 1. Did that make sense? Okay, so the distance between is okay 2 consecutive or 2 adjacent dots or markers is going to be 1 centimeter. So as you okay, may increase the depth of your image. Okay, we can go even as okay to 10 centimeters. The meaning is to see 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Did you guys get that? Any questions? Anybody want to say anything? No? No comments? No punchline? No words of wisdom? Okay, guys. Now on page number 53, you guys have your Bics? Good. And do you see a hint box? Good. Now, this is something that many people may confuse and say, how in the is that possible? Now, I'm not looking at it, but I guess, okay, what it says is that, okay, as your pulse repetition period is not related to your period, right? Is that clear? So don't fall for that. Clear? So what does that mean? Yes, okay, you can have a pulse which may have a greater pulse duration or shorter pulse duration. Clear? Okay, because it has a greater or shorter period for each cycle. But that shorter or longer period is not going to have any effect or is not going to be related to your pulse repetition period. You can have a pulse with a great pulse repetition period. You can have a pulse with a great pulse duration, but a small pulse repetition period or long pulse repetition period. And likewise, you can have a pulse with a short pulse duration, but a great or short pulse repetition period. Because what's going to determine your pulse repetition period is not the pulse duration, but it's actually going to be your off time, which has been adjusted by you changing the depth of the image. Did you guys get that?
Would power and depth be related?
I mean,
Would power and depth be related at all? No. Okay.
not for now. Okay, so that hint box, make sure that you mark it. Clear? So your pulse repetition period is not related to the period of the pulse duration. Clear? Or pulse, or is not related to the period itself. What was period? The time for one single cycle. Did you guys get that? So let me just ask you, is your pulse repetition period related to frequency? Anybody?
I'll say no.
You say no? Okay, why do you say no? Just because it is a yes or no question?
I don't know. I was just thinking
You don't know, you just said no.
I'm just thinking the relationship between period and frequency, and if it's like, I don't know.
Yes,
Okay,
that's exactly why.
love it.
So that's okay. You don't affect me, yes, okay. Then that's how it goes. So yes, okay, the pulse repetition period does not affect the period, or period doesn't affect the pulse repetition period, then neither will frequency.
So the only relationship it would have would be to depth of image, right?
Pretty much for now. Okay, guys, go and take your lunch. Now, before I send you guys on lunch, sorry. Any doubts about depth? Okay. Now, hopefully it's okay when we, it's okay, at some point, it's okay, get to the school and get hold of a machine. I will show you, it's okay, a couple of those knobs that functions, that's okay, practically. What you may, it's okay, just talk about. I've talked about, okay. But for physics, for now, it's okay, at least you need to know the relationships. Clear? Okay. Okay. Okay, guys, I see you guys back at clock 01. 1 o'clock. Let's continue. Okay, guys, so our next topic is going to be, yes, okay, what we'll call the pulse. Repetition. Frequency. Yeah, okay. And again, please keep in mind, yes, okay, this is going to, let me say frequency here. Okay, that's going to be, yes, okay. How frequently is a pulse repeated? And what we mean is, okay, then what we mean by is, okay, how frequently in a time period. So for practical, that's okay. Definition wise, they can mean is okay, what is going to be the pulse repetition frequency? We can say, okay, that's going to be the number of pulses repeated. Okay, yes, okay. In a unit of time. Okay, yes, this unit of time here is what it will be. Oh, sorry. More specific, it will be as okay for a second. Did you guys get that? So guys, what a pulse repetition frequency, which we actually as okay, will be as okay, abbreviating as P R F. Mainly is going to be as okay in a second. How many pulses are going to be repeated, or how frequently is it that okay, yes, a pulse will occur or will be repeated in a time span of 1 second. So let us just do it this way, guys. And says, okay, we have a time span and says, okay, for instance, okay, if this here was 1 second. Right? Okay. Now the pulse repetition frequency is going to be as okay. Now what do we have? Because that's okay, we had a pulse. frequency, okay, that pulse was followed by an. Let me just draw the pulses first. These were our pulses, and okay, yes, those pulses were each followed by an off time. Yeah, okay. But what we see that we have here is, okay, in 1 second, for instance, is that there's going to be, okay, how frequently is it that our pulses are going to be repeated? 1, 2, 3, 4, 5. In a second. Yeah, okay. So we can say it's okay that based on this, it's okay, the pulse repetition frequency is going to be as okay 5 times in a second, or pulse repetition frequency is going to be 5 hertz. Did you guys get that?
Yeah.
Okay. So guys, when we said frequency and frequency only, what did we mean? The number of cycles per second. Clear? Okay. Whereas now when we say pulse repetition frequency, that is going to be as okay, roughly directly saying the frequency of pulses. Did that make sense? Okay. Did you guys get that? Okay. So where you want to count your cycles per second, that will just be the frequency of your cycles, or plain frequency. Clear? Or you want to count your cycle pulses per second, we're just going to be as okay, your pulse repetition frequency. Did you guys get that? Now, likewise, when we say period, when we said period and period only, what was it that we were talking about? Yes, guys. If I said period, that's my
Is it time to complete a cycle?
time to complete a cycle, okay? Whereas if I say it's okay, pulse repetition period, just the time after which a pulse is going to be repeated. Did you guys get that? So pulse repetition period and pulse repetition frequency are mainly as okay, all about as okay, what's the time at which okay as a pulse is repeated. And based on that, we can determine what is going to be the frequency at which a pulse will be repeated in a second. How frequently is okay will a pulse appear or be repeated in a second, but that will become a pulse repetition frequency. Did that make sense? Okay. So as okay, you can express this here as okay as pulses per second, or you can say as okay, the PRF can also be expressed as okay, the regular unit of frequency, which is hertz. Just like period and pulse repetition period. Both could be represented by the unit of time. Clear? Did you guys get that? Now again, guys, sorry. Just like your PRP, typical value, don't worry about it. Clear? Clear. Likewise, typical value for your PRF, don't worry about that one either. Okay, because we just saw that, okay, pulse repetition period can be adjusted. And adjusted to, yes, okay, the wireless numbers. So kind of a pulse repetition frequency also. Now, guys, determined by is determined by the source only. Now, to be more specific, here's okay, what we actually is okay, or mean by the source will be as okay, the ultrasound system. Okay. How? Mainly as okay, just like your PRP that we said, okay, as was adjustable by adjusting depth. Did you guys get that? However, we could, yes, okay. Increase the depth. Or we could increase the depth of your image. That's pretty much okay how we also is okay, we're able to adjust our pulse repetition frequency. Did you guys get that?
Yeah.
Good. Now, guys, let us do it this way. Because now we made us okay, said okay, we had two things. We had something that we call the PRP. Okay, we can just okay. Period. Okay, we have PR is going to be it's okay, pulse repetition. We had something that we call PRF. And let me just write it and say it's okay, because F was going to be it's okay, the frequency at which the pulse was repeated. Okay. And we can mainly say it's okay that in the middle, Now, both of these here is okay, could be as okay adjusted by changing the depth of image. Did you guys get that?
Yes.
Good. Now, do you guys see where I'm going? Does anybody have any wildest imagination of where I'll be going from here? I would
I
like
think they would
to.
be.
Hamida?
Oh, I was going to say they might be inversely related. The period and frequency.
Okay, of course, period and frequency are inversely related. But our pulse repetition period and pulse repetition frequency are going to be inversely related.
They're reciprocals.
Okay. But let's just say first inversely related. And then we can always talk about reciprocal. But if you still are confused on how, well, okay, just think of how was period and frequency generally as okay related. They were inversely related. And they were reciprocal. But that was just for period and frequency generally. But when we check as okay, pulse repetition period, that's just going to be as okay, what's the time span at which is okay, by which okay as a pulse is being repeated. Well, okay, the pulse repetition frequency will just be as okay. Whatever the time is okay, that's going to is okay, be in between is okay, the pulse being repeated. But what's going to be as okay, the number of pulses that we then get in a second will be as okay, the pulse repetition frequency. Which is going to be as okay, the period at which a pulse is repeated, and how frequently is it that a pulse is repeated in a second. Or we can say the period of repetition of a pulse and the frequency at which a pulse is repeated. Or anything measured in terms of time and frequency, but always be inversely related and reciprocal. So we can say that it usually happens. Pulse repetition frequency or period is going to be as okay inversely related to pulse repetition frequency. Not just only that, but your pulse repetition frequency multiplied by the pulse repetition period. Yes, okay. The product of that will be 1. Which we then can say as okay that if we have a greater pulse repetition period, we will have a lower pulse repetition frequency, or vice versa. If we have a low pulse repetition period, we will have a great pulse repetition frequency. Now, another thing that we already also yes, okay, established was that okay, as pulse repetition period, that was also yes, okay, directly proportional to the depth of image. It's mainly meant that okay, yes, due to yes, okay, a greater depth of image, we will have a greater pulse repetition period. And like vice versa. We will have low pulse repetition period if the depth of our image was less. Right? A short journey just to the gas station next door and back will take less time because it was a short distance. A great distance to travel, like from the school all the way down to the highway, would be a greater distance to go and return back from, which means it will require a greater time. Or one person to go and come back before the next could go and come back. Be sent out. Now, whichever way you want to do it, just okay. You just want, just okay, carry on with this and say, okay, when this and this here is okay, were directly related, and this were inversely related, then the depth of image also has to be inversely related to the pulse repetition period. Which mean the opposite. That the lesser the pulse repetition period, because of lesser depth, is going to give us okay as a higher pulse repetition frequency, and vice versa. The greater the depth will have okay as a greater pulse repetition frequency period, and due to that greater pulse repetition period, there will be a lower pulse repetition frequency. But numerically or mathematically, it's only going to be the pulse repetition period that will be as okay inversely proportional, reciprocal to the PRF. So if you may just okay take two examples here and say, now if we had, let's just say that we have this okay, two time spans of 1 second. There okay is here. Let's say it's okay, this is these are our pulses. Okay. Where we have, yes, okay, we still have, okay, it's it's okay, off times. And just so we are all on the same page, because that's where this would have to be fast, that's okay, 1 millisecond. Oh, that's it, okay, 1 second, that's fine. Right, okay. Whereas here, Okay, we can say it's okay, that would have been a pulse that will start here. But then this is okay, will be our off times. So what do we have here? Okay, now we have 3 pulses being repeated in 1 second. So we can mainly say that, okay, yes, in this case, it's okay. The PRF is 3 hertz. Whereas in this case, yes, okay, we have 1, 2, 3, 4, 5, 6 pulses repeated in a second. So the frequency or the pulse repetition frequency will be, sorry, not 3 hertz, 6 hertz. Did that make sense? Okay. Now, since that's the case, that way we mainly can say it's okay that the PRP which will be as okay the time between the 1 pulse to the next, 1 pulse to the next, 1 pulse to the next is going to be as okay 1/3 of a second. Here is going to be 1/6 of a second. Did you guys get that? So when we is okay, so here's okay. And we're going to say this is okay, the greater the PRP, the lower the PRF. The lower the PRP, okay, yes, the greater your PRF. Okay. But it also has to be the okay, yes, when it says okay, multiply this by this, that the product becomes 1. Or it's okay when we multiply this by this, that the product becomes 1. Did you guys get that?
Yes.
Any questions? The last thing will be then B is okay. In which of these two here? We can say it's okay, A and B. Where we have yes, okay, a greater depth of image and a lower depth of image. Now in A mainly is okay because of a greater PRP. We will have a greater depth. Whereas in B, mainly is okay due to the shorter PRP. It's okay, we'll lower depth. Or what we mainly see is okay that okay, the greater the depth, sorry, the greater the depth, lower PRP or PRF. Lesser depth, higher PRF. Because guys, if I send any one of you, let's say it's okay, one of you is going to be it's okay, a pulse, but just coming back and forth, back and forth, back and forth. Now I send you to the gas station and back. You'll be back in, let's say, it's okay, 1 minute. Clear? Okay. That's going to be the time that it takes you to go to the gas station and come back. And when you come back, I send you back to the gas station. Clear? Okay. So you'll be back in 1 minute. How to say is okay, you'll be able to make up to 60 trips in an hour, right? Like that. So your frequency of trips from school to gas station next door is going to be 60 in a minute. In an hour, sorry. Clear? Okay. So that will be as okay, your frequency of trips to the gas station and back in an hour. Clear? Okay. We had a short time, but then a great frequency because of a short distance. Did you guys get that? Clear? Okay. Now, if I send you, yes, okay, down to the highway and come back, let's say that, okay, that trips or that single trip takes you, yes, okay, 10 minutes to go from school to highway and come back. Of course, yes, okay, that's going to be a greater distance, right? So it will take you a longer time. And if I says, okay, how many trips are you able to make in an hour then? If it takes you 10 minutes to go from school to highway and back. So how many trips will you make in an hour?
6.
6. Clear? So what can you, I hope everybody can agree that, okay, yes, 6 is a number that is less than 60, which was going to be as, okay, the frequency of, or the number of trips made per hour in this case here, right? Okay. Why was the number less? Or why was the number of trips less? Because it took you more time to complete a trip. Okay, what did we call that greater time? Was repetition period. What do we call the number of trips that you completed in an hour? In this case, yes, okay. Was repetition frequency. So that's how, yes, okay, these two fellows here are related to one another. And this is how these two fellows here, yes, okay, each are individually, yes, okay, are related to depth. Did you guys get that? Is there anybody who is in doubt? Nope. So right now we're only doing it verbally. Now, if I ask this question in class and I get a wrong answer at that time, verbal may become practical. So whenever you show up, guys, make sure that you have your running shoes. No, probably not. Well, that's okay. Had this been in the military, yes, okay, that would be in the picture. I repeat, you understood and you still didn't follow the orders, that's okay. And I say, okay, so and you just look blankly at me. Like, okay, what the is it the Mike is talking about? I said, okay, so you still didn't get that? Okay, 100 push-ups. No, just kidding. But it's okay. If you at any point it's okay, are lost, well, okay, yes, that's how you it's okay will do it in. Okay, it's okay. Look at it in a day-to-day example. Clear? Okay. Now, of course, that's okay. We are not going to have a pulse repetition period that's going to be 1/3 of a second. Okay, that's going to be a pulse that is traveling like, okay, at the speed of, forget about it. Too slow. Clear, okay? So you actually, yes, okay, will have pulses being repeated, yes, okay, thousands of times in a second. They've done millions. So if you say, okay, if your frequency or if your pulse repetition frequency was 3 megahertz, if your frequency was, or pulse repetition frequency was 3 megahertz, what would be your pulse repetition period then?
Point 3. 0.33.
0.33 what?
Hertz. Wait, you asked.
Since when is period measured in hertz?
I'm sorry. I'm sorry, seconds.
5 seconds.
Or is it milliseconds?
It's not milliseconds either. My dear, if it's micro megahertz, it's going to be microseconds. Kilo is reciprocal to
Milliseconds.
milli. Those two units were reciprocal to one another. Clear? Okay, that's how you can save yourself from a lot of confusion. Did you guys get that? Good. Now, last point. What we can say is, okay, pretty much similar to just, okay, what we did with PRP. Was that, okay, it was not going to be related to period, right? So please, 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 your PRF is not related to your frequency. You can have a sound wave with a high frequency. Clear? You can have a sound wave with a high frequency. But that most likely as okay is going to be as okay ultimately it's being expressed as the frequency of the transducer. But that high frequency transducer can still have a high or low PRF, which is all determined upon the depth that you set it at, right? Your image at. Did that make sense? So since your greater or lower PR is okay frequency is not going to cause your pulse repetition frequency to be as okay high or low. That's how it's okay how they are going to be as okay not affecting one another, and things that doesn't affect one another are unrelated. Yes, Angelis. Angie? I can't hear you there.
Yeah, sorry, I was
Okay. Okay.
trying-
You
Yeah.
want to share the joke with us as well?
No.
No? Why is that kind of joke? You can turn the coughing off, that's fine. Okay. Any questions? So I can give you as okay any crazy question and say as okay, this is the frequency of the transducer. What's going to be the PRP? I have no effing idea. because, okay, they were not related, right? Because PRF is not related to PRP. Just like period is not related to PRP. Frequency is not related to PRF, and likewise not related to PRP as well. Did you guys get that? But simple period and simple frequency will be related. PRP and PRF will be related. How? That's okay, they will have similar relationships. Pulse repetition period is going to be inversely proportional and reciprocal to pulse repetition frequency. Period is going to be inversely proportional and reciprocal to frequency. Clear? But pulse repetition period has no relation with plane period, and as a matter of fact, no relation with frequency either. Did that make sense? Okay. Any questions, guys? So yes, depth of image. Set your pulse repetition frequency. Set your pulse repetition period. Clear? Okay. And please, 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 when I said it, I say it again. In your pulse repetition period, the pulse duration is constant as per transducer. So the only thing that can be changed in a pulse repetition period is going to be the off time, listening time. Are you guys clear about that? Now, guys, any question about pulse repetition period and pulse repetition frequency? No? Okay. I hope that will be yes, okay, remaining like this, because we're going to talk about these two dudes or chicks here further in another chapter. It's going to be a bim bam boom chapter. You guys know a bim bam boom chapter?
Fast.
It's finished before it started. Okay. Where we just will call us, okay, end up talking about us, okay, pulse repetition frequency and pulse repetition period. Actually, it's okay, just by a different term. That's all. And just introducing a little rule, but that rule is where you guys will get stuck. I know from experience. Okay, guys. Have fun. What's the weather like where you are? I can see Jenny is getting some sun.
Yeah, all the rooms in my house, they're just hot mess.
Okay. What is it on Rhode Island, my dear?
Nice and sunny.
Nice and sunny? Okay.
Yeah, it's warm out too.
It's warm. Okay. How far are you from Providence? That's on Rhode Island, right?
Yeah, not that, like 15 minutes.
15 minutes.
Yeah.
Okay, have you ever got a parking ticket?
No.
Have you ever got a speeding ticket?
No.
No, okay. Even if you did, you may not end up paying it, right?
Are you talking about the judge in Rhode
Yeah,
Island?
I'm
Waives
talking about him.
everything.
No, I guess okay. That's what they are for. It should not. Anyways, the other day they said that he got cancer. I read it somewhere.
Yeah, I just saw that too. It's
Um,
really sad.
Okay, guys. Any last words of wisdom? Okay, now I think that's okay after PRF. That's okay. You'll find over on page 59 that says, what's his name? That's okay. There's some 8 nice questions that you can chew on during the weekend. Okay. Good. So Monday, that's okay. We will talk of duty factor. We will talk, okay, maybe a little bit of the questions. And okay, guys, just so you guys are aware, the chapters that will be on your quiz will be 1 to 5. Okay. And 5 is okay as again, probably is okay. Not a bim bam boom, but okay, yes, pretty much okay. One section chapter. So okay, guys. I'll see you guys on Monday with duty factor. Have fun, enjoy your day, and
Have a
take
good
care.
weekend.
And don't
Bye.
speed.
Have a good weekend.
Okay, bye bye, guys.